Good day all and welcome once again to my channel. This time we are going to be having a chemistry video lesson on the shortcuts to naming the alkanols, alkanoates and alkanoic acids. Now these organic families, they are under organic chemistry too. Alright, so firstly we have to understand how to name the alkanols. How do we name the alkanols? Now if you have any organic compound that contains OH, now OH is the functional group of the alkanols, alright? The functional group of alkanols. So that is the functional group. So it means that any organic compound that carries OH or contains OH is an alkanol. And of course, if we have something like this and we are told to name this structure, we are told to name this. Now, this structure has 4 carbons and 10 hydrogens. Now, considering this structure, this is actually a member of the alkanes. Why? Because looking at the alkanes, they are known by their general formula CnH2n plus 2. And since in this case we are having how many carbons? We are having 4. So our N value here represents 4. So it becomes C4H2 times 4 plus 2. That should give us C4H. 2 times 4 is 8 plus 2, 10. So this is a member of the alkanes and it is called butane. Why? It has how many carbons? 4. Now, generally, the alkanols, they are formed from the alkanes. The spelling of alkane is like this. So if I remove this E and I replace it with OL, it gives me alkanol. And by that, it means for you to get alkanol from alkane, you have to remove one atom of hydrogen from alkane for you to get alkanol. Alright? So the thing is this, if I'm having the first member of the alkanes to be methane, if I want to get a corresponding member of this under the alkanol, I will just simply remove the E and replace with OL. Then I should obtain methanol. So if methane is having a formula CH4, then methanol would be having a formula CH3OH. Why? Because I just simply removed one H from here and then I now replaced with OH. So that's how the alkanols they are formed. So this structure, like I said, is what? Butane. Now, if I put OH here and I am told to name this, all you simply do is work with that same butane, which is butane, but this time I will clean off the E. Why? Because there is OH. Remember, OH represents alkanol. So if I'm numbering, this is our longest chain here, carbon chain. So if I number forward and I number backward, then going by forward, the carbon that is carrying the OH is carbon 1. Then backward is what? Carbon 4. So you have to go with the smaller value. So in this case, we are going with the forward direction, which is carbon 1. That becomes butan 1. That is this one. And then OH, which is all. That's the alkanol. Alright. So this compound is called butan 1 all, or you can just simply call it butanol. Yes, because 1 in this case is insignificant. Alright, so that's the name of that compound. What about if I had decided to remove the O and place it here, meaning we are having our OH here. Remember, like I said, this is a functional group of the alkanols. If you are going by forward numbering, the carbon is 2, backward is 3. Remember, we are going with the smaller value. So what should be the name of this? It should be what? Butan 2 all. Alright. So if at all I still remove it here and I position it here, and then I am told to name this, it still remains butan 2 all. Why? If you are going by forward, it is in carbon 3, then backward is in carbon 2. So between 3 and 2, which one is smaller? Is what? 2. So that's why we should go with backward. So this still remains butan 2 all. Then if I remove it here and I position it here, it will now be what? Butan 1 all because of the smaller value. So that's how you name structures like this. Then let's see more. Let's quickly look at more. Let's say we are given this structure and then we are told to name this. How would you go about naming it? Now we have OH and OH. This time we are having three OH groups. All right. Looking at it, it's still the same principle. You simply uh, represent the carbons. How many carbons are there? We are having what? Three. So we start with propan. Why is it propan? Because if assuming there were no OH and there were H here, then the name would have been propane. But now it's propan. Then next, we number forward and backward of the carbons. 1, 2, 3. It's the same thing because we are having OH in all the carbons. So hence, we can say propan 1, 2, 3, which are these numbers, triol. Triol. Why is it called triol? Because we're having 3 of OH in this case. That's why it's called tri. You know that the prefix tri represents what? 3. Alright? So that's why it's called propan 1, 2, 3 triol. So that's how you name that. Then let's see more. Let's see more. Let's say we are given this other one. You are given this and you are told to name this, and then you're having Cl, you're having Br, and then you're having something like this. In this case now we are now having substituents. Then how would you go about naming this? It's still very easy. This still remains our longest carbon chain. 1, 2, 3, 4, 5, 6. That's hexane. Then next, do we have the OH? Of course, yes. And it's positioned there. Do we have substituents? Yes, positioned here. So what are you supposed to do? You number the carbon atoms in both directions, that's forward and backward. All right. Now, are we to go with forward or we are to go with backward? Let's confirm. Considering this guy, OH, and not these other ones. So now, if you are going by forward, the carbon atom carrying it is carbon 5. Backward is what? Carbon 2. So it's obvious we should go with the backward. Why? Because of the smaller value. And mind you, please take note of this. Whenever you are going with a direction, go with it all through. Don't go with forward and you are going with backward at the same time. No. So since it was this guy that determined the direction we are to go with, then we should go with this direction all through. Now this would be what? Hexane 2, which is this 2, all. Then do we have substituents? Yes, 2 of them. And since we are going with the backward, share this B arrow, which is bromo, is seated on carbon 5 because we are going with the backward, remember. So that's carbon 5. Then while this one, that's chloro, is seated on carbon 4. Now next, between B and C, which one comes first in alphabet? It is B. So that's the reason why you should start this name with 5 bromo, then 4 chloro, then what? Hexane 2 all. And as a matter of fact, hexane 2 all can be renamed 2 hexanol. So if I say hexane 3 all, it's the same as 3 hexanol. Butan 2 all is the same as 2 butanol. Alright, so that's how it works. Then the last on naming of this alkanol is the condensed. Let's see a condensed pattern of naming. CH3, CH2, you might see something like this. And then how would you go about naming it? Then now CH3 and OH, then you are having CH2 and CH3. This is like a condensed pattern. When some students see this kind of question and you ask for the IUPAC name, now they get scared or probably they'll be confused. You don't have to be confused. When you are giving something like this, you have to expand it to make it easier. Now in this case, I can draw this CH3 in this pattern. This and this, they are the same. CH3, CH3. Then the carbon is linked to this guy. And then this is now CH2, which is H and H, CH2. Then next is this carbon. This bracket simply signifies that the carbon is carrying the CH3 and as well as OH. Alright, these two are directly attached to this carbon. Then next, we have the CH2, which is this guy, and the last one is CH3. Alright, so we have been able to expand everything. So what are we supposed to do next? This is our longest chain. How many carbons are there? One, two, three, four, five. Five. That should be what? Pentan. Pentan. Then next, we number forward and backward. One, two, three, four, five. One, two, three, four, five. Now, where can you find your OH in this carbon? And going by forward, backward, they are the same. So you can go with any direction. And again, our substituent, this CH3 stands for methyl. So this is our substituent there. It's still seated on the same carbon. So we can go with any direction. So if we are going with any direction, it should be what? Pentan 3 all. Then do we have the substituent? Yes. So what position can you still find the substituent? The third carbon, which is 3 methyl. 3 methyl pentan 3 all. Alright. So that's how you name compounds under the alkanols. So you can do well to check for more questions on naming of alkanols. Let's quickly look at the alkanoids. Now, considering the alkanoids, they are also called what? They are also called esters. Esters. And they are known by their general formula arrow COO. Whenever you see arrow represents alkyl group. And when we say alkyl group, it could be any of the members of the alkyls. It could be methyl, ethyl, propyl, or the rest. I can represent this structurally as RC, then OR. Alright, so this and this, they are the same. That's for the esters. So how would you go about naming the esters? Let's see. Let's say we are given CH3, then CH2, then COO, then CH3. This is an example of ester. Now you are told to name this. How would you go about it? All you simply do, split this into three parts and name the last alkyl group as first, and name the first alkyl group together with the carbon atom of the functional group as last. I know so many students will be confused now, but you don't need to be confused. Just be very attentive. Now, these are the alkyls. We have methyl. Now, methyl is CH3. Then we have ethyl. Ethyl is C2H5. We have propyl. Propyl is C3H7. Then we have butyl. Butyl is C4H9. All right, let's just stop there. Now, I said name the last alkyl group as first, and the first alkyl group together with the carbon atom of the functional group as last. How? This guy, CH3. What's CH3? Methyl. So I will say methyl. Then, how many carbons are left after you've eliminated this guy? You are left with 1, 2, and 3. And 3 carbons represent what? Prop. So you end it with propanoids. That's how you name it. Is that easy? Now, let me bring another one so that you understand better. All right. Now, let's say we are given something like this. We are given C4H9, COO, C2H5. Now you are told to name this. How would you go about it? Split into 3 parts, don't forget. Last alkyl group as first. Then the first alkyl group and the carbon of the functional group as last. So what does that mean? This guy here is what? Ethyl. So you start the name with ethyl. Then how many carbons are left after you have removed this guy? We are left with what? 5, because this is 4 plus 1, 5. And 5 carbons is pent. So you should end it with pentanoids. That's how you name it. Let's say we are given something like this. And then we are told to name this compound. Now, how would you go about naming it? It's very easy. You split it again into 3 parts, and then you name the last alkyl group, don't forget, as first, and the first alkyl group alongside with the carbon atom of the functional group as last. Simple. Now, what's this? This guy is propyl. So we say propyl. Then how many carbons are left since we have eliminated this guy now? We are left with what? 6. 5 plus 1, 6. That should be what? Hexanoid. Because 6 carbons is hex. Alright? So when you combine, it becomes propyl hexanoid. So the next that we'll look at would be on the naming of alkanoic acids. Alkanoic acids. Now, when we say alkanoic acids, we are referring to compounds that usually carries the COOH group. All right, this is the functional group of the alkanoic acids. All right. So now, if you are told to name compounds like this, how would you go about naming them? Because normally their general formula is arrow, COOH. Remember, arrow represents what? Alkyl group. Alkyl group. All right. So hence, if I have C2H5 COOH and I am told to name this compound, how would I go about naming it? It's very easy. Now, how many carbons are there in this compound, the entire compound? How many carbons are there? 3. 2 plus 1 here is 3. And 3 carbons represents what? Prop. So you call this propanoic acid. That's the name. There was a time that this question came out in JAMB for those writing JAMB. C4H9 COOH. Now, students were asked for the name of this compound. Now, how would you name it? From what I've just taught now, 4 plus 1 is what? 5. And since we have 5 carbons in total, 5 carbons is what? Is pent. So you call this pentanoic acid. Why am I ending it with noic acid? Because it's a member of the alkanoic acid. Is that easy? So what about if I am giving, let's say, structural representation? For example, let's say I am giving something like this, and then I am told to name this compound. What should be the name of this? What should be the name of this? Now, it will be very easy in that how many carbons are here in total? 1, 2, 3, 4. And since it carries the COOH, then you can call it butanoic acid. Why is it called butanoic? But is what? With 4 carbons. All right. So it's that easy. Even if they come in the form of condensed pattern, for example, they can ask you, now, what is the name of this compound? The name of this compound. How would you go about naming it? It's not hard. So long it contains COOH, you know you have to end it with noic acid. Then next, how many carbons are here in the entire compound? 1. Then this 6, remember, is affecting everything here. So it means we are having 6 carbons here, plus 1 is 7, plus this one now is what? 8. And 8 carbons is with what? Oct as the prefix. So hence you call this what? Octanoic acid. That's how you name it. So that's just the shortcut to naming the alkanols, alkanoic acids, and alkanoates. All right. So do well to follow, as you know, I upload more video lessons. If you are yet to subscribe to this channel, do well to hit the subscribe button, or you are yet to follow, you can follow. Then share this video if you find it interesting to your friends, so as for them to benefit also. Stay glued to this channel as more video lessons will be uploaded soon. Thanks for watching and remain blessed.